Hi guys, welcome back to YouTube channel Chemistry Live UGPG. Today we are going to talk about alkenes and alkynes by elimination reaction and its formation. So this is in accordance with NEP syllabus. So I have a simple message for you guys. Please think for innovation, be creative, learn everywhere, anytime and help to learn others. So this is the syllabus, fundamentals of organic chemistry, major to minor to paper. So today we will be talking about formation of alkenes and alkynes by elimination reactions. So let's talk about the first method, the formation of alkene by dehydration of alcohol. So let's start with ethanol. So if we use dilute sulfuric acid and if you heat it, you will get the simplest alkene. So this is the mechanism, how this reactant is converted to the product. So H2SO4 we know that is a ionic compound. So that ionizes to give H plus and HSO4 minus. And this is the structure of ethanol. So oxygen has lone pair of electrons, so it can act as nucleophile. So this lone pair will attack to the electrophile H plus. So it becomes OH2 plus. And this bond will break on OH2 plus. So as a result we get CH3 CH2 plus. So once we get this carbocation, so HSO4 minus again will take the proton and this CH bond will break on here. So as a result we get the alkene due to the elimination of this water. So let's take another example. So if you start with this alcohol, so we react with H plus and water, we get this alkene. So this OH has lone pair of electrons, so it will act as nucleophile, so it will attack to the proton H plus. So nucleophile will attack to the electrophile, so it becomes OH2 plus. So now this OH2 plus, this CO bond will break on OH2 plus. So as a result you generate a carbocation here. So now here the ring expansion takes place, so this CC sigma bond will migrate to this carbon. So as a result you end up with this carbocation. So now this water will take this proton and this CH bond will break on here. So as a result you generate this alkene. So if we take another example, this bromide. So if you use tertiary butoxide, you will get this cyclohexene. So this butoxide anion will take this proton and this CH bond will come here and it will kick out Br as Br minus. So you end up with alkene, the cyclohexene. So this is coming under E2 mechanism. So next method is dehydrohalogenation of alkyl halides. So you start with this ethyl bromide and you use alcoholic KOH and heat. So you get this alkene, CH2 double bond CH2. So this is the mechanism. So we have alcoholic KOH means OH minus ion is there. So this OH minus will take this proton and this CH bond will come here and it will kick out Br as Br minus. So as a result you get this simplest alkene. This is coming under E2 mechanism. Next method is debromination of a vicinal dibromide. So if you start with this dibromide and you use sodium iodide and acetone and heat, you will end up with this alkene. So here is the mechanism. So I minus will attack to this bromine and this CBr bond will break here and it will kick out Br as Br minus. So you end up with this alkene. Similarly, if you start with this dibromide, so you can use also zinc acetic acid. So you will get this simplest alkene. So here is the mechanism. So this dibromide first react with the metallic zinc. So oxidation number is 0. So you will get this ZnBr. So this is just similar to the Grignard reagent. So C minus and ZnBr plus. So when the C minus will come back, it will kick out Br as Br minus. So you will end up with this alkene plus ZnBr2. Now next talk about formation of alkynes by elimination reaction. So first method is dehydrohalogenation of vicinal dihalides. So this is the vicinal dibromide and you use alcoholic KOH. You will first end up with this compound, then you further react with sodium sodamide. You will end up with alkyne. So here is the mechanism. So this OH minus ion will take this proton, and here this CH bond will come here and it will kick out Br as Br minus. So you will end up with this mono-bromo derivative. So we have this NaNH2 minus. So this NH2 minus will take this proton and this CH bond will come here and it will kick out Br as Br minus. So you will end up with this alkyne. The next is dehydrohalogenation of a trans 2-bromo 2-butenes. So this is the trans 2-bromo 2-butene. So if you react with sodamide, so NH2 minus will take this proton and this CH bond will migrate here and it will kick out Br as Br minus. So you will end up with this alkyne. The next method is dehydrohalogenation of a geminal dichloride. So this is the 1,1-dichloro 1-cyclohexyl-ethane. So if you use alcoholic KOH, you will end up with this alkyne. So here is the mechanism. So OH minus ion will take this proton and the CH bond will move here and it will kick out Cl as Cl minus. So you will end up with this intermediate. So again this OH minus ion will take this proton and the CH bond will come here and it will kick out Cl as Cl minus. So you will end up with this terminal alkyne. Similarly, the reaction of metallic zinc with the tetrahalides. So this is the tetrahalide and you react with 2 equivalent of zinc. You will end up with alkyne. So this tetrahalide, first you react with metallic zinc. So you get ZnCl similar to the Grignard reagent. So when this C minus will come back, it will kick out Cl as Cl minus. So again you react with this compound with metallic zinc. So you will end up with again ZnCl. So the C minus will come back, it will kick out Cl as Cl minus. So you will end up with this alkyne. So please subscribe to our channel Chemistry Live UGPG. So this is the channel for class 11 and 12 students, Foundation Chemistry AB. This is a simple step towards e-learning, making life better. Thank you all for learning.